So I have given book, right, in your WhatsApp group, right? So for the cast iron, I have taken from that book only. You can read out, right, from that book. All you got, right? Have you seen that book?
यस सर, मैंने ग्रुप पे भेज दिया था सर.
Okay.
Yes, sir.
So we will wait again 2 minutes. Let them come. Right. After that, we will start stainless steel, and we will see mechanical properties of materials, right, in this class. Any international students or any NRI students is there in this group?
No sir.
Oh. Right. So I think you got the your schedules of the exams, right? So there will be surprise tests and class tests, right? So that will be counted for your means marks, right? I think it is on the website, right? So you can see that one. Right. So I'm going to present, right, PT stainless steel. I think it is showing on your screen.
Yes, sir.
Yes, sir.
Okay. So in last class we have seen that why it is called stainless, right? It is rustless, or it is having corrosion resistance, right? So due to the this oxide formation. Right? So there are different types, right? The higher the carbon content, lower will be the corrosion resistance of stainless steel. Right? That means higher the carbon content, lower will be the corrosion resistance. Means this is indirectly proportional. Right? So there are 5 types. Right? So if you see the name, first 3 name, right? Austenitic, ferritic, and martensitic. Right? These words already you know. Right? So austenitic means if you see the iron carbon diagram, austenite phase is there, right? Ferritic, ferrite phase is there. Martensitic, martensite will form by rapid cooling, right? Fourth one is precipitation hardening, right? So there will be precipitations, right, in this precipitation hardened stainless steel. And fifth one is your duplex structures, right? In duplex structures, what is happening? Two different phases are mixed. That's why it is called duplex structure. So by the name you can understand what will be the difference, right? So one by one we will see. See the any materials, if it is there, you have to write composition, properties, applications. If it is there in microstructures, then you have to write the microstructures, right? So austenitic, it is denoted by 200 and 300 series, right? 2010, 2030, right? Like that. Uh, Chromium composition is chromium, nickel, manganese, and iron. Right. So I think I have given some table also. Right. Table is there. Right. So it is there. Right. Table is also there. Right. you can see detailed composition, right? Detailed composition you can see, right? So you just remember that chromium has to be there, right? And another percentage of carbon it is there, common percentage, right? And nickel and magnesium, right? So you have to write at least chromium and carbon percentage, right? So composition is nickel, chromium, nickel and manganese in iron. Right? Properties is non-magnetic and have excellent corrosion resistance, but they are susceptible to stress corrosion cracking. Right? What is this stress corrosion cracking? Right? So due to the corrosion, right, there will be some cracking happening, right, inside the materials, right? That is nothing but and that due to that one stress is developed, right? First stress is developed inside the material due to the corrosion, then crack will form, right? So they may be compressive stresses or tensile stresses, right? So
Trial
that is
version.
nothing but hello. And are hardened by
Sir,
cold working. Yes.
sir, if it is cracking because of corrosion, so how can we say that it is corrosion resistant?
Uh, so there is a percentage again, percentage of matter, right? तो जो है देखो स्टील के ऊपर आपने यूटेंसिल्स देखे होंगे घर पे, राइट? उसमें डॉट्स आ जाते हैं। स्टेनलेस स्टील के ऊपर भी कोरोजन होता है, ऐसा नहीं है कि 100% कोई भी मटेरियल कोरोजन नहीं होगा, राइट? देयर विल बी ऑलवेज बी चांसेस, राइट, हैविंग अ कोरोजन। इवन आपका जो कार्स हैं, राइट, जिसके ऊपर क्रोमियम प्लेटिंग की जाती है, राइट, जनरली क्रोमियम प्लेटिंग की भी जाती है, राइट, हैविंग टू हैव अ हायर फिनिश एंड रस्ट करोजिव होने के लिए। मगर आफ्टर सम टाइम्स देयर विल बी सम डॉट्स ऑन द सरफेस, राइट? तो डॉट्स क्यों हो जाते हैं? क्योंकि वो ये हो जाता है कि उसको बोलते हैं पिट्स, राइट, पिट करोजन, राइट? तो वो उसमें भी ससेप्टिबिलिटी होती है। ऐसा नहीं है कि आप 100% क्रोमियम तो आप यूज नहीं करोगे, राइट, बिकॉज इट्स डोंट हैव द मैकेनिकल प्रॉपर्टीज, only some percentage you will add, right? So it depends on that how much you are adding that chromium, right? तो 100% किसी का भी लाइफ नहीं होता है, 100% कोरोजन रेजिस्टेंस कोई नहीं होता है, मगर उसमें एंटी कोरोजन प्रॉपर्टी जो है ज्यादा है, राइट? तो इसमें जो है स्ट्रेस कोरोजन क्रैकिंग की पॉसिबिलिटी ज्यादा है, राइट? एंड दे आर, आई थिंक यू आर गेटिंग माय पॉइंट।
Yes, sir.
तो अगेन सी दैट द कंपोजिशन मैटर्स अ लॉट, राइट? केमिस्ट्री है, उसमें जो केमिस्ट्री रहेगी दैट इज इम्पोर्टेंट, that can be hardened by cold working, right? Most ductile of all stainless steels and can be formed easily, right? So ductility and malleability है इसमें, right? You can say forming also, formability, right? कप शेप में फॉर्म किया जा सकता है इसको। तो आपको जो एप्लीकेशंस है, किचन वेयर्स है, फिटिंग्स, वेल्डेड कंस्ट्रक्शंस, लाइट वेट ट्रांसपोर्टेशन इक्विपमेंट, फर्नेस एंड हीट एक्सचेंजर पार्ट्स, components for several chemical environments, right? So these are the applications, right? तो उसमें इसको एग्जाम पॉइंट ऑफ व्यू कैसे याद रखना है? अगेन यू हैव टू गो फॉर द आयरन कार्बन डायग्राम। आयरन कार्बन डायग्राम में आपको जो है ऑस्टेनिटिक्स की क्या प्रॉपर्टीज रहती है कंपेयर टू योर फेराइट, राइट? तो यू कैन इजीली कंपेयर दैट वन। Next one is a ferritic stainless steel, right? It is denoted by 400 series. These steels have a high chromium content up to 27%. So properties are magnetic and have a high good corrosion resistance, but they are have lower ductility than austenitic stainless steel. कम डक्टाइल होता है, right, compared to your stainless steel. ये क्यों होता है, right? Again, you have to go for the chemistry. Chromium percentage is higher, so there will be, due to that one, the ductility is lower. Right? Ferritic stainless steels are hardened by cold working and are not heat treatable, just like your MS mild steel. That is not heat treatable. This ferritic stainless steel is also not heat treatable. You cannot heat treat, right? So heat treated मतलब soft या hard नहीं कर सकते इसको. They generally use for non-structural applications such as kitchen equipment and automotive trims. तो क्योंकि इसमें क्या है कि हीट ट्रीट नहीं कर सकते हैं, right? So you cannot get as per your requirement, right? जो toughness चाहिए, hardness चाहिए, right? That you cannot change the chemistry, right? So generally it is used for the kitchen equipment and automotive trims. Right? देखो kitchen equipments यहाँ पर भी है, वहां पर भी है, right? तो आपने बहुत जगह देखा होगा कि किचन वेयर्स में कुछ आपके यूटेंसिल्स हैं, कुछ क्रैकिंग आ जाती है उसमें, right? If it is in very cold condition or in very hot conditions, right? So sometimes it is due to the stress corrosion cracking. Right? Then you have to change the chemistry in the stainless steel. जनरली जो आपके थिन शीट्स होती हैं, राइट, वो क्रैक हो जाती है. So next one is the martensitic stainless steel. It is denoted by a 400 and 500 series. So it do not contain nickel and are hardenable by heat treatment. Their chromium content may be as much as 18%. So it is magnetic and they have a high strength, hardness and fatigue resistance, good ductility, moderate corrosion resistance. These are the properties. So applications are cutlery, surgical equipment, instruments, valves and springs. Right? Yes, ये क्यों है इसमें सर्जिकल इक्विपमेंट्स वगैरह, क्योंकि इसका हीट ट्रीटेड कर सकते हैं. You can have a specific springs for the tools and instruments. इसको कैसे याद रखा जाए, right? You can have your own idea, but there are 5 types: ferritic, austenitic and martensitic. These 2 words you can get from the iron carbon diagram. Precipitation is one thing and duplex is you are mixing 2 atoms, 2 means structures, phases. So next one is a precipitation harden. What is precipitation? I think this word you have used in chemistry lab. 11th में था.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Same thing is there. This contains chromium and nickel and along with copper, aluminum, platinum or molybdenum. So you have to add it and precipitate it. So this precipitation hardens steel and all things. In detail it is there in second year also. The same topic it is there in the second year also. Stainless steel. Right. So properties are good corrosion resistance, ductility, and they have high strength at elevated temperatures. Applications are aircraft and aerospace structural components. So what is happening due to the application process, you can have a higher strength, right, at elevated temperatures. So you can go for the precipitation hardened stainless steel or the aircraft and aerospace structural components. Next one is a duplex structure stainless steel. It is a just a mixture of austenite and ferritic stainless steel. Right? इसमें क्या है डुप्लेक्स जो वर्ड है राइट यू आर मिक्सिंग टू steels austenitic and ferritic, right? So properties are they have a good strength and have higher resistance to both corrosion and stress corrosion cracking than do the 300 series of the austenitic stainless steel, right? जो austenitic stainless steel का problem है stress corrosion cracking, right? You can avoid by using duplex structure, right? So it is having both properties of austenitic stainless steel and ferritic stainless steel, right? So what are the applications? Water treatment plants, right? So in water treatment plants, what is there? They are more susceptible. Parts are more susceptible to corrosion, right? So there you can use duplex structures. And in heat exchanger components, right, where there is a high heat, right, you can use duplex structures, right? So this duplex structures and precipitation hardened stainless steel, right, this is our newer one, and nowadays they are using much more compared to your other stainless steels, because especially where you require a higher strength, right, at elevated temperatures. That means in aerospace and aircraft industries they are using this stainless steels. So for the compositions and other mechanical properties, you can go through this one, right? So compositions, right? So what's the thumb rule for the chromium percentage, right? I have indicated in first slide. And carbon percentage you have to write. Other things I will don't mind, right, as far as your exam is concerned, right? So you should know the types, right, their applications, and they're having some problems with respect to your heat treatment, and you can do heat treatment in some stainless steels, you cannot do in another stainless steels. Stress cracking problem is in one steels, you can avoid that stress corrosion cracking in another steels, right? So these points you have to remember. This is all about the stainless steel and their types, right? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
तो इसमें देखो एग्जाम से अगर पहले पढ़ लोगे तो याद नहीं रहेगा, इसमें बहुत सारी चीजें भूल जाओगे आप, राइट? तो थोड़ा सा पढ़ते रहना चाहिए. एंड यू आर फ्रॉम ऑल मैकेनिकल ना? यू ऑल फ्रॉम मैकेनिकल?
Electrical.
इलेक्ट्रिकल एंड मैकेनिकल
Production.
मिक्स है. अच्छा,
So electrical, mechanical, and production and industrial.
ओके. तो देखो इंडस्ट्रियल प्रोडक्शन और उसके लिए तो मुझे पता है, बट इन इलेक्ट्रिकल, राइट, यू हैव metallurgy subject is there, I think in second year or third year, right? You will study the materials in terms of your electrical properties, right? What are the electrical properties and all these things for the all materials, right? So in that respect, you can study this. As far as your core branches are concerned, civil, electrical, mechanical are core branches, and it is always useful to have a this initial materials studies, right? So next topic we will see the mechanical properties of the materials. So I will send this PPTs after the class is over, right? I will stop this sharing and then I will search, open it, and then
Hello.
yes, I am opening that one, right? It's open. I think I will share it. Right. So material and their mechanical properties, right? It is showing on your screen.
Yes, sir.
Yes, sir.
Okay. So any material you take, what are the properties you have to see, right? Forget about the mechanical properties. Other properties we will discuss, right? First, right? It may be a physical properties, right? Physicals means volume, weight, melting temperature, freezing temperature, right? These are all the physical properties. Then comes electrical properties, conductivity, flux, and all these things, right? And then magnetic properties are there, right? And physical, electrical, magnetic, right? And some of the having semiconductor as having doping like that properties are there, right? So as far as this subject is concerned, we are concerning with only mechanical properties, right? So there are different, so many properties are there. I think near about 15 properties, right? 13 properties are there, right? So you should know the definition of these properties. So what is strength? It is the ability of material to resist the externally applied forces without breaking. Right? That is its strength. So in the second year or afterwards, we will see. You can see that how to check these strengths. Right? It may be yield strength, it may be tensile strength, it may be a compressive strength. How to check it on the machines, right? There are different machines are there, but UTM is universal testing machine is there, right? You have to make one bar, right? And you have to pull it. Tensile, you have to apply the tensile load, right? So after some load, there will be a cracking on that part, right? So you can draw your stress strain diagram with respect to your load, right? Right. So stress is nothing but your force per unit area, right? And your strain is change in length divided by original length, right? So you can draw the stress strain diagram and you can indicate its yield point, right? Yield strength, ultimate tensile strength, right? Compressive, if it is a you are applying the compressive load or it may be a tensile load, right? So that you can indicate on the stress strain diagram. That is the indication of your strength, right? And in book it is thoroughly explanation is there, right? You as far as syllabus is concerned, this is enough. Only definition is enough, right? If you are interested in depth, you can go through book and read out. Next point is stiffness. It is the ability of material to resist deformation under stress. Right? It is the ability of material to resist deformation under stress. What is the difference between stress and pressure? So units of pressure is Newton per mm square, and stress unit is also
सर
Newton per
सर
mm square.
स्ट्रेस में सर फोर्स परपेंडिकुलर होना चाहिए सर.
परपेंडिकुलर ऐसा नहीं है, एंगुलर हो सकता है, पेरीफेरी पे हो सकता है.
ओके सर.
इंटरनल. तो बेसिकली स्ट्रेस, आपको भी स्ट्रेस आता है, पढ़ाई का स्ट्रेस आता है, तो दैट इज नॉट एक्सटर्नल वन, दैट इज इंटरनल वन. स्ट्रेस बाहर से नहीं आता, अंदर से आता है. The same concept is there, right? So generally stress is internal one,
Sir.
and pressure is external one, right? So ऊपर से pressure आएगा तो नीचे से stress develop हो जाएगा. That is the case, right? Even in testing, right? Material testing, if you apply external load, right, then only internal stresses gets developed, right? किसी कोई आपने रॉड ले लिया या प्लेट ले लिया, उसको बेंड किया, राइट, यू आर अप्लाइंग एक्सटर्नल लोड, राइट, so that it is creating some stresses inside the material. That is the thing, right? So if you are taking about the fluid and all that pressure, right, fluid pressure रहता है, right? अब अगर पास्कल लॉ की बात करते हैं, that is the different case, right? तो वो यूनिफॉर्म होना चाहिए, परपेंडिकुलर होना चाहिए, right? That is the different case. That is we will study in the part A, right? Pascal's law and all these things. Next point is the modulus of elasticity is a measure of stiffness, right? So modulus of elasticity, what is modulus of elasticity? Stress divided by strain, right? That you can calculate and you can indicate the stiffness of the material. Elasticity, right? It is a property of material to regain its original shape after deformation when external forces are removed, right? That means if you want to convert the sheet metal, right, and you that sheet metal plate is converted into cup shape part, right? Right? अब प्लेट ले लिया है, right, स्क्वायर शेप में, उसको अपने कप शेप में फॉर्म कर दिया, राइट. फॉर्म करने के बाद इफ इट इज रिगेन इट्स ओरिजिनल शेप, राइट, दैट शीट में कन्वर्ट होता है, दैट मीन्स इट इज फुल्ली इलास्टिक मटेरियल, एंड दैट इज नॉट द केस फॉर एवरी मटेरियल, राइट. अगर शीट मेटल अगर यूज करते हैं तो अगेन इट विल बी नॉट डिफॉर्म्ड 100%, इट विल नॉट रिगेन इट्स 100%, मीन्स कप शेप में 100% फॉर्म नहीं होगा, ना ही वो एग्जैक्टली स्क्वायर प्लेट में कन्वर्ट होगा, राइट. सो फुल्ली इलास्टिक एंड फुल्ली प्लास्टिक, इट इज नॉट एग्जिस्ट, राइट, एज फार एज मीन्स रियलिटी इज कंसर्न, राइट. फुल्ली प्लास्टिक, फुल्ली इलास्टिक कोई मटेरियल नहीं होता है, राइट. आप डिफॉर्म करने के बाद regain shape नहीं होता है, right? Stresses always be there. This property is desirable for materials used in tools and machines. It may be noted that steel is more elastic than rubber. Steel is more elastic than rubber, right? Clear हो गया ये?
Yes, sir.
Yes, sir.
Next point is plasticity, right? Elastic and then plasticity. It is the property of material which retains the deformation produced under load permanently, right? How much percent is permanently deformed? That is plasticity. This property of material is necessary for forging, in stamping images of coins and ornamental work. राइट, जो आप स्मिथ शॉप है, स्मिथ शॉप में आप जो चीजल बनाओगे या फिर कोई भी कंपोनेंट्स है आपका, ये कनेक्टिंग रॉड है या फिर आपका क्रैंकशाफ्ट है, राइट. So all these parts you want particular shape, right? Particular shape में convert करना है उसको, right? By using external load, right? तो उस केस में आपको plasticity is desired for that material. Next point is ductility. Ductility. It is the property of material enabling it to be drawn into wire with application of tensile force. Right? Ductility material must be both strong and plastic. Ductility is measured by the terms percentage elongation and percentage reduction in area. Ductile material commonly used in engineering practice in order to diminishing ductility are mild steels, copper, aluminum, nickel, zinc, tin, lead. Right? So ductility is just a property to convert it into thin wires. The ductility of material is commonly measured by means of percentage of elongation and percentage reduction in area in tensile test. Right? जैसे जैसे आप वायर में कन्वर्ट करोगे उसको, आपका क्रॉस सेक्शनल एरिया कम होता जाएगा. That is the indication of your ductility. Right? That material's ductility. Brittleness. Next property is brittleness. It is the property of material opposite to ductility. It is the property of breaking the material with little permanent distortion. Right? Brittle materials, when subjected to tensile load, snap off without giving any sensible elongation. Cast iron is a brittle material. Okay? So if you apply the tensile load, they start fracturing it. Right? That is the indication of brittle material, and it is just opposite to your ductility property. Right? Next one is a malleability. Right? Again, it can be converted into thin sheets. A malleable material should be plastic, but it is not essential to be so strong. The malleable materials commonly used in engineering practice are lead, soft steel, right, wrought iron, copper, and aluminum. This the malleability property. I think we are here at the malleability property, right? Next one is the toughness. It is the property of material to resist fracture due to the high impact loads, like hammer blows. Right? So to resist the impact load, you require toughness. The toughness of a material decreases if it is heated. It is a measure by the amount of energy that a unit volume of a material has absorbed after being stressed up to the point of fracture. Right? So by two properties it can be defined, right? Resistance against the impact load and amount of energy is absorbed by the material after applying the external load. This property is desirable in parts subjected to shock and impact load. So जहाँ पे shocks आते हैं, impact load आता है, the desired property is toughness. जैसे गियर के टूथ पे आता है, गियर चेंज करते समय impact load आ जाता है, instantly speed is changing and that instantly you are applying the external impact load on the gear tooth. Right? तो shaft है, आपका gear tooth है, right? Crank shafts है, right? connecting rod है, right? These are the all parts, right? Require the properties toughness. Next one is the machinability. It is the property of material which refers to a relative case with which material can be cut. Right? The machinability of material can be measured in number of ways, such as comparing the tool life for cutting different materials. So machinability is of machining, right? Easy to cut, that is its machinability property. तो मशीनेबिलिटी कैसे चेक की जाती है, राइट? एक तो टूल लाइफ है, राइट? टूल की लाइफ कितनी देर तक चलेगी, राइट? और थ्रस्ट रिक्वायर्ड टू रिमूव द मटेरियल एट सम गिवन रेट और एनर्जी रिक्वायर्ड टू रिमूव द यूनिट वॉल्यूम ऑफ मटेरियल. तो कितना एनर्जी लगता है, कितना लोड लगता है, उसका लाइफ कितना है, राइट? ये तीन फैक्टर्स पे आप मशीनेबिलिटी काउंट कर सकते हैं. It can be noted that brass can be easily machined than steel, right? तो brass क्या है? Copper plus zinc. Brass is alloy of copper and zinc. Copper is also soft material, right? And zinc, by zinc strength is, you will get the strength, but compared to steel, right, brass is easily machinable. Resilience. It is the property of material to absorb energy or to resist shocks and impact loads, right? So there will be confusion, right? Resilience and your toughness, right? It is measured by an amount of energy absorbed per unit volume within elastic limit, right? This is important if you compare toughness and resilience, right? Within elastic limit. This property is essential for स्प्रिंग मटेरियल. स्प्रिंग में रेजिलियंस होना चाहिए, तो स्प्रिंग्स में टफनेस भी होना चाहिए, रेजिलियंस भी होना चाहिए, राइट? क्योंकि अप टू इलास्टिक लिमिट इट इज कॉल्ड रेजिलियंस, अप टू द फ्रैक्चर पॉइंट्स इट इज कॉल्ड टफनेस. क्लियर है? आवाज आ रही है?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
The properties.
Yes, sir.
आ रही है ना आवाज?
Right, sir.
Okay. Next property is grip. When the part is subject to constant stress at high temperature for a long period of time, it is undergoes slow and Hello?
थोड़ी गलत आ रही है सर. हाँ सर, अब सही आ रही है.
आ रहे हैं. Otherwise I will open this captions. I will add it. Creep. When a part is subjected to a constant stress at high temperature for a long period of time, it will go a slow and permanent deformation called creep. Suppose I have taken a bar, right, steel bar, right? I have put on my house, right, in hanging position, right, and it is for high temperatures and for long period of time. Suppose 5 years I kept that one, right, in a hot temperature, right? So what is happening? It will bend, right? That bending is nothing but the permanent deformation, right? So you can say that this bar is having low creep value. Right? So creep is nothing. Generally, creep is required in high temperature applications, which is used for the longer period of time. Right? So boiler है आपका, combustion engine है, turbines है, jet engines के जो भी parts होते हैं, right? So creep property is very important, right? As far as jet engines are concerned. Right? Next is fatigue. Right? When a material is subjected to repeated stresses, it fails at a stress below the yield point stresses. Okay? Such type of failure of a material is known as a fatigue failure. Right? तो repeated cycles है उसमें, right? So और below yield point से below उसका अगर failure हो जाता है, that is called a fatigue failure. Right? The failure is caused by means of progressive cracks formation. Right? What is this progressive crack? Right? So first some cracks will be generated on the surface and it's prolonged in some directions inside the material. Right? Progress हो जाता है वो crack का, which are usually fine and are of microscopic size. This property is considered in designing shafts, connecting rods, springs, gears, etc. So fatigue life calculation is very important as far as your product's life is concerned. नहीं तो ब्रेक हो जाएगा और पूरा फेलियर हो जाएगा, सिस्टम फेलियर हो जाएगा उसमें. तो फटिग फेलियर बहुत इंपॉर्टेंट है, जो कि जिस पार्ट्स में मूवमेंट हो रही है बेसिकली. जिस पार्ट्स में मूवमेंट हो रही है, जैसे गियर्स है, गियर रोटेट हो रहा है, स्प्रिंग्स का ये हो रहा है, एक्चुएशंस हो रहा है, कनेक्टिंग रॉड्स राइट रोटेट हो रही है, राइट शाफ्ट्स रोटेट हो रही है, कनेक्टिंग रॉड्स आपका जनरली कनेक्टिंग रॉड्स ये होती है आपका स्लाइडिंग मूवमेंट होती है, स्लाइडिंग मूवमेंट होती है उसकी, राइट कनेक्टिंग रॉड की. और यू कैन से there will be ups and downs in the connecting rods. वो उसमें फटिग इम्पोर्टेंट है. So hardness, the property, it is very important property of the material and has a wide variety of the meanings. Right? So it embraces very different properties such as a resistance to wear, right? Resistance to wear, resistance to scratching, deformation and machinability, etc. Right? जो भी resistance है, right? To wear, scratching, deformation and machinability. तो उसको हम hardness बोलते हैं. It is also means the ability of material to cut another material. Right? जो hard material है वही soft material को cut कर सकता है. Right? So by comparing, right, cutting properties, you can say also you can compare the hardness of the material. The hardness is usually expressed in numbers which are dependent on the method of making the test. Right? तो जो hardness number होता है, right, एक number होता है that is unitless number, right, unit नहीं होता है उसमें, right? So they are giving the numbers, right, by that numbers you can find out the hardness of that material. Right? Again test, there are different tests are there. Right? So first one is a Brinell hardness number, right? Rockwell hardness number is there, Vickers numbers, right? And Shor-Solesko number, right? So these are the basically different tests are there, right? So what they are doing, generally doing in Brinell hardness test, they are using steel balls and they are applying the loads through that balls, right? Whatever may be the impression on the material, right? It indicates that the hardness. समझो ज्यादा हार्ड है तो उसका जो पेनिट्रेशन है कम रहेगा. अगर सॉफ्ट है तो इट विल पेनिट्रेट मोर. तो जो बॉल का डेप्थ है वो ज्यादा जाएगा. That is the indication. And again they are converted into a numbers that is called Brinell hardness number. That is in short form that is called BHM, Brinell hardness number. And Rockwell hardness test is there. Again they are using some prism types of right balls, right, that will be impinged on the surface and again they will converted into numbers, RC number. They are called Rockwell hardness number, RC. Because hardness numbers is like
So your voice is not clear.
hello. I think it is showing on my screen, right? Hello. I think voice is clear now.
Yes,
Yes,
sir,
sir.
it's clear now.
Yes, sir.
So these are the tests. Weaker hardness numbers is there. They are generally used for the thicker sheets, right? And again, fourth one is solar scope. Scope is there. Again, they are for the rubbers. They are using the bounce. They will bounce the balls on the surface of the sheets, right? According to the heights of the bouncing elements, right? That will be converted into the hardness. Right? That is the properties of your. These are the properties of materials, right? Especially mechanical properties. Right? You understood this one? All these mechanical properties. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
From where you have to read it. But I think I have.
Yes, sir.
So if you go this is your group, right? Right. So I have given this book to you. So mechanical behavior testing, manufacturing properties of materials, right? So there are some it is there, right? Impactory, fatigue, right? Hardness. Some of the properties are there, right? You can read out. So again, physical properties are there. Right? So in this section, you can read some properties, right? Mechanical behavior testing and manufacturing properties of materials. Right? So what is the difference between bending and torsion? Right. Again, that is not there, but just I am asking. You see, stainless steel are there, right? Hello, आवाज आ रही है?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, आ रही है.
हाँ, तो ये 5th चैप्टर में से आप उसमें से स्टेनलेस स्टील वगैरह पढ़ सकते हैं, राइट? कास्टिंग ऑफ इंगॉट्स एंड स्टेनलेस स्टील्स, राइट? बट फर्स्ट you study from the PPTs, then you go to the book, right? First syllabus, then my PPTs, then book, right? If it is not in this book, you refer that one, Hajra Chaudhary, right? Right. Is there any issue? Right? Any doubts?
No, sir.
No, sir.
Surprise,
No, sir.
सर सरप्राइज टेस्ट इस मंथ होगा या जनवरी से शुरू होंगे?
After I will take after completion of your first unit.
ओके
सर
सर, थैंक यू.
सर आप जिस वीक में सरप्राइज टेस्ट लेंगे सर बता दीजिएगा सर.
जी नहीं, I am directly telling that after completion of first unit, right? First unit is somewhat lengthier one, right? So whenever it is completes, right,
Yes, sir.
I will take the surprise
सर अगर
test,
बाय
right?
चांस किसी स्टूडेंट का सर मिस हो गया तो सर वो दोबारा उसका रीटेस्ट होगा या फिर सर 0 मार्क्स लग जाएंगे मतलब?
और रीटेस्ट का देखो एज पर ऑर्डर तो कुछ लिखा नहीं है रीटेस्ट करने का,
यस सर.
तो ये है सिलेबस जैसे ही खत्म हो जाएगा, राइट, फर्स्ट यूनिट का, तो बी रेडी फॉर दैट वन, दैट
Okay,
इज द
sir.
इंडिकेशन. So I will indicate that the first unit is completed, right? So that is the indication of the your surprise test.
Okay, sir.
Yes, sir.
ठीक है, तो सौरभ मुझे अटेंडेंस दे दोगे ना?
यस सर, मैंने ले लिया है सर स्क्रीनशॉट. मैं भेज दूंगा सर आपको एब्सेंटीज के रोल.
हेलो,
हाँ सर, मैंने स्क्रीनशॉट ले लिया. मैं आपको एब्सेंटीज के रोल नंबर भेज दूंगा सर.
हाँ हाँ,
ठीक है सर.
आपका
सर
आवाज कम क्यों आ रहा है मुझे? आपका आवाज कम क्यों आ रहा है मुझे?
सर अब सही है सर.
हाँ ठीक है, तो वो
सर,
करके
मैं
मुझे
भेज दूंगा.
दे देना फिर.
ठीक है सर. ठीक है सर. बाय सर.
ओके.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you,
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
भाई किसी ने फीस भरी है?